What if every choice you've ever made, every path taken or left behind, existed simultaneously in another universe? Picture a version of you reading these words right now, while another you is halfway across the galaxy, living a life so different it feels like a dream. This isn't just a thought experiment, it's the spine-tingling premise of multiverse theory, where reality splinters into infinite possibilities, each as real as the one you're experiencing now. But here's where it gets even wilder. The deeper we dive into this cosmic puzzle, the more paradoxes emerge, twisting our understanding of existence into knots. Think about the last decision you made, what to eat for breakfast, whether to take that job offer, even the route you drove home. In the multiverse, every single one of those choices branches into a new timeline, creating a web of alternate realities so vast it defies imagination. And yet, this isn't just speculative fiction. Groundbreaking discoveries in quantum mechanics suggest these parallel worlds might be more than hypothetical. They could be the hidden architecture of the cosmos itself. So why does this matter to you? Because these paradoxes aren't just academic curiosities, they're clues to the very nature of reality, forcing us to question everything we thought we knew about time, space, and even our own identities. Over the course of this journey, we'll unravel 28 of the most astonishing paradoxes in multiverse theory, each one a doorway to a deeper mystery. Some will bend your mind with their sheer impossibility, like the idea that you could meet another version of yourself, only to realize neither of you is the original. Others will challenge the laws of physics, revealing gaps in our understanding so profound they hint at realities beyond our wildest dreams. This exploration isn't just about science, it's about the limits of human perception, the nature of choice, and the haunting question: if infinite versions of us exist, what does that say about free will, destiny, or even the meaning of life? Strap in, because by the end, you'll never see the universe or yourself the same way again. Imagine a cat in a box, alive and dead at the same time until someone opens it to look. That's the classic Schrödinger's cat paradox, a mind-bending thought experiment that reveals the bizarre nature of quantum mechanics. But now, throw the multiverse into the mix, and things get even stranger. In one universe, you open the box to find a purring, very much alive cat. In another, the outcome is tragically different. But here's the kicker: both versions of reality exist simultaneously, forever unobserved by each other. This isn't just about a hypothetical cat, it challenges the very foundation of how we perceive reality. Quantum mechanics suggests that particles exist in multiple states at once until observed, a concept called superposition. But in a multiverse, observation doesn't collapse these possibilities into a single outcome. Instead, every possible outcome plays out somewhere, splitting reality into infinite branches. So, did your observation cause the cat to live or die? Or was that outcome always destined for some other version of you in a parallel world? The implications are staggering. If every quantum possibility spawns a new universe, then death itself becomes a strange illusion. In one reality, a person might cease to exist, while countless other versions of them carry on, oblivious. This blurs the line between life and death in ways that unsettle even the most seasoned physicists. Worse still, it forces us to ask, if all outcomes are equally real, does choice even matter? Or are we just passengers riding one thread in an endless tapestry of predetermined possibilities? Philosophers have wrestled with this for decades. Some argue that the multiverse doesn't erase free will, it just stretches it across dimensions, meaning every possible version of you exercises choice in their own way. Others counter that if every decision spawns a new universe, then nothing is ever truly decided. The cat is always both alive and dead, and so in a sense are we forever fractured into infinite variations of ourselves, each one convinced their reality is the only one that counts. The Fermi Paradox hits different when you bring the multiverse into the equation. If infinite universes exist, each brimming with endless possibilities, why does ours feel so eerily quiet? Statistically, space should be buzzing with interstellar civilizations, advanced societies building megastructures, sending signals, maybe even dropping by for a cosmic visit. And yet our radio telescopes hear nothing but silence. This isn't just a puzzle, it's a screaming contradiction when layered over multiverse theory. Consider this: in a sea of infinite realities, the odds of not encountering intelligent life should be astronomically low. So where's everybody? One chilling possibility is that advanced civilizations inevitably hit a self-destruct button, maybe through war, runaway AI, or ecological collapse. In this scenario, every universe where life reaches our level of technology eventually snuffs itself out, leaving behind empty galaxies like tombstones. But here's where the multiverse twist kicks in. What if we're not just unlucky? What if we're alone in a way that defies probability? Some theories suggest we're living in a desert universe, a rare, isolated bubble where the conditions for intelligent life are freakishly unusual. Imagine winning the cosmic lottery, but the prize is solitude. In most other realities, life might fizzle out before reaching sentience, or physics itself could be tweaked in ways that make complex organisms impossible. Our universe, then, isn't just one of many, it's a cosmic fluke, fine-tuned for us to exist, but devoid of neighbors. Then there's the darker fringe idea. What if extraterrestrial civilizations are out there, but they've mastered dimensional travel, slipping between universes like pages in a book? If that's true, they might be all around us, invisible because they operate in realms beyond our perception. Picture ants on a sidewalk, unaware of the humans walking overhead. The multiverse could be teeming with life, just not in any form we're equipped to recognize. This paradox forces us to confront uncomfortable questions. Are we the universe's way of understanding itself, or just a fleeting accident in an indifferent void? And if infinite versions of reality exist, does that make our loneliness more tragic or more miraculous? The silence isn't just empty space, it's a riddle wrapped in the fabric of existence itself. What if everything you know, your memories, your sense of self, even the world around you, is nothing more than a fleeting glitch in the fabric of reality? This is the unsettling heart of the Boltzmann Brain paradox, a thought experiment so bizarre it makes Schrödinger's cat look tame. Picture this: in an infinite multiverse, where time stretches endlessly and particles dance randomly through the void, the laws of probability suggest something unsettling. Given enough time, a fully formed, self-aware consciousness could spontaneously pop into existence, complete with fabricated memories of a past that never happened. Think about that for a moment. Your entire life, every birthday, every heartbreak, every moment of joy, could just be an illusion conjured up by cosmic chance. You might not be a living, breathing human at all, but a disembodied brain floating in the emptiness, dreaming up reality as you go. The worst part, there's no way to prove it isn't true. Statistically, in an infinite multiverse teeming with random fluctuations, Boltzmann brains should outnumber real, organic minds by an unimaginable margin. So why does the world feel so solid, so consistent? This paradox isn't just a quirky philosophical puzzle, it strikes at the foundation of how we trust our own experiences. Science relies on observation and repeatable results, but what if our observations themselves are hallucinations? Some physicists argue that the very fact we perceive an ordered universe is evidence against the Boltzmann brain scenario. After all, a randomly generated mind would more likely experience chaos, not the intricate patterns we see around us, but others counter that even that could be part of the illusion, a self-contained fantasy designed to feel real. The implications ripple outward. If Boltzmann brains are possible, then the multiverse isn't just a collection of alternate realities, it's a hall of mirrors, where nothing can be trusted. It undermines the certainty of history, the reliability of science, even the nature of identity. Are we explorers uncovering the secrets of the cosmos, or just ghosts in the quantum machine, destined to dissolve back into the void the moment we realize the truth? Yet there's a twist. Some interpretations suggest that the very existence of this paradox might hint at deeper laws of reality we haven't uncovered yet. Maybe the universe has built-in safeguards against such freak occurrences, or perhaps consciousness itself is something more fundamental, an anchor in the chaos. Either way, the Boltzmann brain forces us to confront a humbling question. In a cosmos of infinite possibilities, how do we know anything for sure? Here's a terrifying thought: what if you couldn't die, no matter how impossible the odds? Not because you're invincible, but because somewhere in the multiverse, there's always a version of you that survives. This is the spine-chilling premise behind quantum immortality, a paradox that twists the knife on our deepest fears about mortality. Picture standing in front of a firing squad. The guns fire, but in one reality, a misfire or a sudden distraction spares your life. From your perspective, you'd only ever experience the timelines where you live, creating the illusion that death simply skips over you. But here's where it gets ethically murky. For every version of you that dodges death, countless others meet their end. That's the unsettling trade-off of infinite branching realities. You might feel like the luckiest person alive, but statistically, most versions of you aren't. This isn't just theoretical quantum suicide. A grim thought experiment pushes the idea further. Imagine a device rigged to kill you based on a random quantum event, like the spin of an electron. In most universes, the device activates and you're gone. But in a handful, you inexplicably survive. From your viewpoint, you'd keep winning the quantum lottery, watching in horror as the odds against you grow exponentially impossible. What does this mean for how we value life? If consciousness always follows the path where it persists, does death become meaningless? Or does it make each death more tragic, knowing it's just one thread snipped in an endless tapestry of possibilities? Some argue this paradox strips mortality of its weight. After all, if you never experience the end, does it even count? Others counter that it's the ultimate existential horror, an eternity where you're statistically doomed in almost every reality, clinging to the sliver where you persist. Then there's the haunting question of identity. If infinite versions of you are constantly dying, are you truly surviving, or just the last one standing in a cosmic game of elimination? The you that lives might feel immortal, but it's a hollow victory when the cost is an infinite graveyard of alternate selves. This paradox doesn't just bend physics, it warps our very notion of what it means to exist. If immortality is just a trick of perspective, does living forever become a curse, or the ultimate loneliness? Time travel stories love to torment us with the grandfather paradox. What if you went back and accidentally prevented your own existence? Classic time loop logic says you'd vanish in a puff of cosmic contradiction, erasing yourself from history, but the multiverse flips this nightmare into something even stranger. Imagine stepping into the past and stopping your grandparents from meeting, in a single universe model that should unravel your entire timeline, yet in the multiverse, your interference doesn't erase history, it forks it. One reality continues unchanged with you still very much alive, another branches off, a bleak world where you were never born. So here's the real question: which timeline do you experience? The answer might lie in quantum immortality's eerie logic. Just as your consciousness seems to dodge death by always landing in realities where you survive, time travel could work the same way. You never witness the timeline where your actions erased you because you can't exist there to observe it. Instead, you'd always find yourself in a universe where your meddling either failed or created a new, messy alternative. But this raises a darker possibility. If every decision spawns new timelines, then time travelers might be cosmic arsonists, leaving behind countless doomed realities with every jump. Picture a version of history where your grandparents never met, your parents were never born, and an entire branch of humanity simply isn't. That world still exists, frozen in its tragedy, while you obliviously continue your adventures elsewhere. The multiverse doesn't solve the grandfather paradox, it multiplies it, turning one grim thought experiment into infinite unresolved tragedies. Philosophers call this the self-healing universe hypothesis. Reality doesn't collapse under paradoxes, it sidesteps them by spawning new branches where the rules still make sense, but this leaves us with a haunting uncertainty. If time travel is possible, how many alternate histories have we already lost to careless travelers? And if every choice creates new worlds, are we already time travelers, splitting reality with every decision we make? The grandfather paradox isn't just about changing the past, it's about the fragility of cause and effect. In a multiverse, nothing is ever truly undone. Actions don't vanish, they ripple outward, leaving behind ghost timelines where the unimaginable happened, and no one is left to remember. The idea that our universe might be an elaborate simulation isn't new, but throw the multiverse into the mix, and the stakes get exponentially weirder. If we're living in a programmed reality, who's to say our creators aren't themselves trapped in a simulation, like cosmic Russian dolls stacked inside one another? Picture this: a civilization in a base-level universe builds a hyper-realistic simulation of their own world, complete with conscious beings. Those simulated beings, unaware their code, eventually create their own simulations, and so on, spiraling into an infinite regression of fabricated realities. The chilling question isn't just are we in a simulation, it's how deep does the rabbit hole go. Here's the nightmare fuel: if simulations can spawn simulations, the odds of us living in the one true base reality shrink to practically zero. Statistically, we're far more likely to be somewhere in the middle or bottom of that endless stack, and if each layer runs on the computing power of the one above it, our universe might be running on hardware so diluted, even the laws of physics could be glitches in someone else's code. Ever experienced déjà vu, or noticed reality behaving in ways that seem off? Those could be more than coincidences, they might be artifacts of the simulation's architecture, like pixels bleeding through from a higher layer. But here's where the paradox tightens its grip. If simulations are indistinguishable from reality to those inside them, how could we ever prove we're not in one? Some scientists suggest hunting for resolution limits in the fabric of space-time, tiny, unexplained gaps in energy, or patterns that hint at underlying programming. Others propose that quantum randomness isn't random at all, but the result of computational shortcuts, like a video game reducing detail in areas the player isn't observing. Even our attempts to uncover the truth might be part of the script, with every breakthrough pre-programmed to keep us chasing shadows. The multiverse twist makes this even more unsettling. If every possible universe exists, then somewhere out there, a civilization did discover they were in a simulation, and what happened next? Were they deleted for figuring it out? Did their creators hit reset, trapping them in an endless loop of ignorance? Or worse, what if we're the failed run of an abandoned experiment, left running in the background like forgotten software? The simulation hypothesis doesn't just question reality, it turns existence into a hall of mirrors, where every reflection is another layer of someone else's design. And the most haunting thought of all, if we're just lines of code in an infinite chain, does that make our suffering less real, or our yearning for meaning just another programmed illusion? If every possible choice you could make spawns a new universe, then who, or what is really pulling the strings? The many worlds interpretation of quantum mechanics paints a cosmos where every fork in the road splits reality, from life-altering decisions to the tiniest quantum fluctuations. But this raises a haunting question. If all outcomes already exist somewhere, is your choice just an illusion, a predetermined script playing out across infinite stages? Think of it like this: you're standing at a vending machine, debating between soda and water. In one universe, you press the button for soda and walk away. In another, you choose water, but here's the catch: both versions of you feel equally convinced they made a free decision. The unsettling truth: the multiverse doesn't care which button you press. Both outcomes were always inevitable, baked into the fabric of reality the moment the universe began. This isn't free will, it's a cosmic buffet where you're forced to sample every dish, with no say in the menu. Philosophers and physicists are locked in a fierce debate over this paradox. Some argue that free will isn't destroyed, it's democratized. Every version of you exercises agency within their own timeline, like actors improvising within a play where every possible line is performed simultaneously. Others counter that true freedom requires the power to shape reality, not just ride its branching paths. If you can't choose not to split into infinite copies, then your decisions are just ripples in a preordained tide. The implications cut deep. Love, regret, ambition. Do these emotions hold weight if every road not taken is still traveled by another you? A version of you marries their high school sweetheart, another becomes a recluse in the mountains. Both are equally real, equally valid. This doesn't just challenge moral responsibility, it redefines what it means to live with consequences. If every mistake is corrected somewhere else, does growth lose its meaning? Yet there's a twist. Some interpretations suggest that consciousness itself might be the wild card, the one force that collapses probability into a single, lived experience. Maybe the multiverse isn't a prison of predetermined paths, but a canvas where our attention selects which thread to follow. The debate rages on, but one thing is clear: in a cosmos of infinite possibilities, the line between choice and destiny has never been blurrier or more tantalizing to unravel. We've always been told that consciousness shapes reality, but what if its influence doesn't stop at the edges of our universe? The observer effect, that strange quirk of quantum mechanics where particles behave differently when watched, takes on a terrifying new dimension when you consider the multiverse. Imagine peering into a lab experiment, a photon acting as both a particle and a wave until you look, forcing it to choose. Now picture this: your observation here doesn't just collapse possibilities in your world. It sends shockwaves through infinite others, nudging alternate versions of reality into alignment. This isn't just wild speculation. Some interpretations of quantum physics suggest that observation might be a cosmic glue, binding parallel worlds together in ways we don't yet understand. Think of a room filled with identical radios, each tuned to a different station. Your consciousness isn't just listening to one, it's subtly adjusting the dials on all of them at once. Under this model, every decision you make, every moment of attention, could be resonating across dimensions, influencing realities you'll never see. But here's where it gets eerie. If consciousness can ripple through the multiverse, could beings in other worlds be shaping our reality too? Picture a version of you in a distant universe, running a similar experiment at the same time. Their observation might be the reason your results skew unexpectedly, like a ghost hand tweaking the data from beyond the veil. Ancient cultures spoke of doppelgängers and shadow selves. Could these myths hint at a deeper truth about entangled awareness across dimensions? The implications spiral outward. If observation links universes, then free will becomes a collective endeavor. Your choices aren't just yours, they're negotiations with infinite other versions of yourself, all tugging at the fabric of shared reality. Some physicists argue this could explain strange statistical anomalies in quantum experiments, as if particles are responding to observers we can't perceive. Others warn it might mean our universe isn't as isolated as we think, that we're part of a vast, whispering network of worlds. constantly influencing one another beneath the surface of perception. Yet there's a haunting counterpoint. What if this interconnectedness isn't harmonious? Imagine warring civilizations in alternate timelines, each trying to bend reality to their will through sheer focus. Or worse, what if our universe is the quiet one, buffeted by the unchecked observations of more dominant realities? The observer effect doesn't just question the nature of reality, it suggests we might be players in a game whose rules we've only begun to glimpse. And the most unsettling question of all, if consciousness is the architect, who or what is holding the blueprint? What if the mysterious force holding galaxies together isn't hidden in our universe at all, but leaking in from another? Dark matter, the invisible scaffold of the cosmos, has baffled scientists for decades. We can see its gravitational fingerprints, stars orbiting too fast, galaxies clinging together when they should fly apart, but the substance itself remains maddeningly out of reach. Now imagine a radical solution. Dark matter might not belong to our universe. It could be ordinary matter from a parallel reality, bleeding through the cracks between worlds like light seeping under a door. Think of two soap bubbles floating side by side. Where they touch, their surfaces mingle, creating a ghostly bridge between them. In the same way, certain multiverse theories propose that neighboring universes could brush against ours in higher dimensional space, transferring tiny amounts of mass across the divide. To us, that transferred matter would appear invisible because it's not our matter. It doesn't interact with our light, our atoms, or our detectors, but its gravity remains, tying galaxies together with unseen hands. This isn't science fiction. It's a legitimate hypothesis called the mirror matter model, where every particle in our universe has a shadowy twin in another. The implications are staggering. If dark matter is just ordinary stuff from a parallel cosmos, then our universe is far from isolated. We're entangled with unseen neighbors, their presence felt only through subtle tugs on the fabric of space-time. Some theories even suggest these leaks could go both ways, meaning our own matter might be dark matter in another universe, haunting their scientists just as theirs haunts ours. Picture civilizations in these mirror worlds, equally perplexed by the unexplained gravity bending their galaxies, never realizing the answer lies just a dimensional whisper away. But here's where it gets thorny. If matter can slip between universes, what else might be crossing over? Energy, information, could entire structures, stars, planets, even life drift into our cosmos unnoticed? Some researchers speculate that dark matter halos around galaxies might not be amorphous clouds, but the faint traces of parallel celestial bodies, forever out of reach. Others warn that these cosmic leaks could destabilize the delicate balance holding our universe together, like a slow puncture in the fabric of reality. The dark matter multiverse hypothesis doesn't just solve one mystery, it replaces it with a labyrinth of new questions. Are we standing at the edge of an interdimensional shore, sensing the tide of another world, but never seeing its source? And if so, what happens when the tide rises? The classic twin paradox has twisted minds for over a century. Send one sibling rocketing through space at near light speed while the other stays grounded, and when they reunite, the astronaut twin returns younger, their biological clock slowed by relativity's ruthless math. But layer the multiverse onto this thought experiment, and suddenly, age gaps become the least unsettling part. What if the returning twin doesn't just step back into their original timeline? What if they're slipping sideways into a nearly identical, but fundamentally different version of reality? Imagine the traveler's homecoming, hugs with family, familiar streets, everything almost as they remember, yet tiny discrepancies creep in. A childhood photo where the lamp was on the left, not the right, a friend who swears they never had that inside joke. At first, these feel like glitches in memory, but in a multiverse where every quantum event spawns new branches, the truth is far stranger. Their near-light-speed journey didn't just bend time, it may have shunted them onto a parallel world line, one where history diverged imperceptibly while they were gone. This isn't just about missed birthdays. It forces us to ask, what makes a reality yours? If you leave Earth and return to a universe where your favorite coffee shop never existed, are you still you, or has the continuity of your identity been fractured? Philosophers call this the Theseus paradox of the self. If every atom and memory that defines you exists in multiple realities, which version gets to claim your name? The twin floating between worlds might not even notice the swap, their consciousness seamlessly stitching the gaps, never realizing they're living another version's life. The physics gets thornier. Relativity already warps time like taffy near light speed, but quantum mechanics suggests the traveler's path could decohere from their twin's timeline entirely. Each acceleration, each gravitational slingshot around a star, might nudge them onto a new branch of reality's infinite tree. By the time they return, Earth's timeline could have forked countless times, leaving their original siblings stranded in a universe that's now forever out of reach. Here's where it chills the blood. If multiverse theory holds, every interstellar journey could be a one-way trip, not through space, but through the fragile fabric of identity itself. Astronauts might become unmoored from their home reality, destined to drift between close but not quite worlds with every voyage. This doesn't just redefine space travel, it turns exploration into existential roulette. How many heroes have we already lost this way? Their homecoming celebrations happening in realities just inches and infinity away from where they began. The twin paradox was always a tale of time's cruelty, but in the multiverse, it becomes a ghost story about what we lose when the universe resets the stage behind our backs. If coming home means landing in a world where your childhood dog never knew you, or your mother's eyes are the wrong shade of brown, does distance even matter anymore? Or is every journey, in the end, just a leap into the unknown, with no way to prove you ever really came back? There's a twisted game of chance that defies everything we know about survival, one where the rules of probability seem to bend in your favor, but the cost is beyond comprehension. The quantum suicide thought experiment takes the eerie logic of quantum immortality and cranks it up to unbearable extremes. Picture a scientist strapped to a machine rigged to a quantum trigger, maybe the spin of an electron or the decay of a radioactive atom. Each time the device activates, a 50-50 chance determines whether it fires a lethal pulse or does nothing at all. In one reality, the scientist's story ends in an instant. But in another, they walk away unscathed, reset the experiment and pull the trigger again, and again, and again. Here's where the math turns against you. With each attempt, the odds of surviving plummet. 90% chance of death after just a few trials, 99.9% after a dozen. Statistically, you should have been gone long ago, but from your perspective, you'd only ever experience the vanishingly rare timelines where you keep beating the odds. It's like flipping a coin 1,000 times and always landing on heads, not because you're lucky, but because every time it lands on tails, you cease to exist. The universe doesn't conspire to save you, it simply branches into a graveyard of unseen tragedies, leaving only the survivors to wonder why death keeps passing them by. This isn't just a macabre puzzle, it forces us to confront the nature of consciousness itself. If your subjective experience clings to the lone reality where you persist, does that mean your self is somehow special, or are you just the inevitable statistical outlier in an ocean of corpses? Philosophers call this the anthropic bias, the idea that we only observe universes compatible with our existence, blind to the infinite failures, but when applied to quantum suicide, that bias becomes a hall of mirrors where survival feels less like a victory and more like a glitch in the system. The ethical weight of this paradox is crushing. Every time the scientist resets the experiment, countless versions of them perish, each one a fully realized consciousness snuffed out mid-thought. Yet from the survivor's viewpoint, those deaths are abstract, invisible, as distant as a dream upon waking. This splits morality into irreconcilable halves. Is it monstrous to keep gambling with infinite lives, or meaningless, since every loss is erased from your perception? Some argue the experiment proves free will is an illusion after all. If you can't experience failure, do you ever truly choose to stop? Others counter that it's the ultimate test of empathy. Can you care about versions of yourself you'll never meet? Then there's the haunting loophole this paradox exposes in quantum theory. If consciousness really does follow the path of least resistance, always landing in realities where it persists, could we use this to cheat death indefinitely? Imagine a future where the terminally ill strap into quantum chambers, betting their consciousness will hop onto a timeline where their disease spontaneously remits. The implications spiral into dystopia, hospitals filled with comatose patients existing in superposition, families grieving over empty beds while somewhere, a version of their loved one walks out cured, oblivious to the carnage left behind. Quantum suicide doesn't just blur the line between life and death, it turns existence into a cosmic horror story where survival isn't triumph, but the inability to perceive your own extinction. And the most unsettling question isn't whether you'd always live, it's whether you'd ever know the difference if you didn't. Imagine a library so vast it contains every book ever written and every book that could be written. Jorge Luis Borges dreamed up this nightmare in his eerie short story, The Library of Babel, where endless galleries house every possible combination of letters, from profound truths to nonsensical gibberish. Now stretch that idea across the multiverse, and the implications become terrifying. If infinite realities exist, then somewhere, there's a universe where the history books tell a story you've never heard, where World War II ended differently, where the pyramids were built by a civilization we've never discovered, or where your own childhood memories are chronicled in perfect detail, but none of it matches what you remember. This isn't just about alternate history. The infinite library paradox suggests that fact itself might be a local phenomenon, true in your universe, but utterly false in another. Think of a book in this cosmic library titled The Complete and Accurate History of Your Life. In your world, it's a work of fiction, but in a neighboring reality, it's a documentary. The same applies to prophecies. A prediction that sounds absurd in our timeline might be unfolding with eerie precision in another. Even this script you're hearing right now could exist verbatim in a universe where it's being recited by an artificial intelligence that isn't you, to an audience that doesn't include you, about events that never happened to you. The real horror isn't just that these contradictory truths exist, it's that there's no way to prove which version is original. Your reality's history might be another universe's fantasy novel. Ancient myths dismissed as folklore in our world could be cold, hard facts elsewhere. This turns the very notion of objectivity inside out. If every possible narrative exists somewhere, then knowledge becomes a hall of mirrors, where the reflections disagree on what's real. But here's where it gets philosophical. If an infinite number of books call themselves the true history of Earth, how do we decide which one to trust? Some argue this makes truth meaningless, just a quirk of whichever universe you happen to occupy. Others counter that it elevates skepticism to a survival skill. After all, in a multiverse of infinite lies, the only defense is to question everything, yet there's a haunting silver lining. If every story exists, then every mistake has already been corrected somewhere. Every tragedy has a timeline where it was averted, every regret a version where you made the other choice. The library doesn't just house contradictions, it holds every possible redemption. The catch: you'll never know if you're holding the right book, or if you're just a footnote in someone else's. You've probably had that eerie feeling of seeing someone who looks just like you, a stranger with your smile, your walk, maybe even your voice. Now imagine that person isn't just similar, they're identical down to the last atom, sharing your memories, your fears, even the same childhood scar on their left knee. In the multiverse, this isn't a glitch, it's inevitable. Given infinite realities, there's a version of you reading these exact words right now, living your life in perfect parallel. But here's the mind-bending twist: if you stood face to face with them, would you be looking at a mirror or a stranger? This is the Doppelganger Dilemma, a paradox that shreds our most basic assumptions about identity. We like to think of ourselves as singular, unique collections of experiences and choices that no one else could replicate, but in a cosmos of infinite branching timelines, that uniqueness collapses. Somewhere out there, another you chose the same career, fell in love with the same person, and paused at this exact sentence with the same furrowed brow. So what separates you from them? If your thoughts, emotions, and even your brain chemistry are identical, are you fundamentally the same consciousness stretched across two bodies? Or does the mere fact of existing in separate universes make you irreversibly different the moment your worlds diverge? Philosophers call this the Theseus paradox of the self. If every component of a ship is replaced over time, is it still the same ship? Now apply that to you. If another version of you shares all your original parts, memories, atoms, even soul, if such a thing exists, are they still you, or have they become something else by occupying a different point in the multiverse? Some argue that identity is rooted in continuity, the unbroken thread of experience tying your past self to your present. But if your doppelganger has that same unbroken thread, just in another reality, the lines blur terrifyingly fast. The implications ripple outward. If you met your double, would you owe them the same moral consideration as yourself? Could they claim rights to your possessions, your relationships, even your name? Legal systems crumble under these questions. Imagine a courtroom where the defendant isn't just like you, they are you, with identical fingerprints and DNA. How could justice account for infinite versions of every crime, every victim, every perpetrator? Then there's the existential horror lurking beneath it all. If countless copies of you exist, each equally valid, what happens to the idea of legacy? Every achievement, every failure, becomes meaningless when it's simultaneously yours and not yours. A version of you cures cancer while another invents warp drive, but also one who never left their hometown, and another who didn't survive childhood. In the face of infinite selves, how do you measure a life's worth? Yet here's the strangest part: even if you accept that your doppelgangers are technically you, your gut screams they're not. There's an uncanny valley of the self, a primal revulsion at the idea of sharing your identity, no matter how perfect the match. This might be the paradox's deepest truth. Identity isn't just about what's in your head or your genes. It's about the irreducible, unexplainable feeling of being you, a feeling no duplicate, no matter how exact, could ever truly replicate. The Doppelganger Dilemma doesn't just question who we are, it forces us to ask whether who we are even matters in a cosmos where every possible version of us already exists. Are we individuals, or just temporary patterns in an infinite kaleidoscope? And if the answer is the latter, does that make us insignificant or part of something impossibly vast? What if simply looking at reality could freeze it in place, not just in your universe, but across every possible version of existence? The quantum Zeno effect, a bizarre quirk of physics, shows that the act of observing a quantum system can literally slow down its evolution, like pressing pause on a particle's behavior by staring at it too hard. Now take that concept and stretch it across the multiverse, and the implications become staggering. If every observation locks reality into a specific state, does that mean conscious beings are unknowingly handcuffing infinite parallel worlds to their choices? Picture a radioactive atom on the verge of decay. Left alone, it'll eventually split, but bombard it with constant measurement, and something strange happens. The atom stays intact, as if terrified to change under the spotlight. This is the quantum Zeno effect in action, observation acting like a cosmic glue, trapping reality in a moment of stasis. Now imagine that same atom existing in multiple universes, each version decaying or not decaying based on its own timeline. If a conscious observer in one universe keeps measuring it, could their gaze ripple outward, forcing every other version of that atom to freeze in place too? Think of the multiverse as a vast, interconnected network of domino chains. Normally, each universe's dominoes fall independently, but what if observing your own dominoes somehow reached across dimensions, propping up dominoes in other realities to keep them from tipping? Some interpretations of quantum mechanics suggest exactly that. Conscious observation doesn't just collapse possibilities in your world, it sends shockwaves through the entire multiverse, synchronizing parallel realities into eerie alignment. The ethical weight of this is crushing. Every time you check the time on your phone, every glance at a traffic light, every medical scan in a hospital, could these mundane acts be imposing your version of reality onto countless other worlds? Philosophers call this observational imperialism, the idea that one universe's choices might override the natural diversity of the multiverse. A civilization obsessed with measuring quantum states could, in theory, flatten infinite possibilities into a single, monotonous timeline. But here's the terrifying counterpoint. If observation locks reality into place, what happens when competing observers try to freeze it differently? Imagine two scientists in separate universes, each relentlessly measuring the same quantum system, one trying to force it into state A, the other into state B. Does reality split again to accommodate both, or does some deeper, hidden law of the multiverse decide which observer wins? This isn't just theoretical. Some physicists speculate that black holes' natural cosmic observers with their event horizons might be already doing this on a galactic scale, their relentless gravitational gaze freezing quantum fluctuations across entire clusters of realities. The quantum Zeno effect doesn't just challenge our place in the multiverse, it turns observation into a weapon of mass stabilization. We think of ourselves as passive witnesses to reality, but what if we're its prison guards, slamming doors on possibilities we'll never see? And the most unsettling question isn't whether we're freezing other worlds, it's whether something somewhere is doing the same to ours. Remember that childhood movie where the villain definitely said, "Luke, I am your father, except wait, he never actually did," or the time you swore the Monopoly man wore a monocle, only to discover he never had one? These aren't just faulty memories, they might be cracks in reality itself, fleeting glimpses into alternate timelines where history unfolded just slightly differently. The Mandela Effect, named after the eerie phenomenon where thousands vividly recall Nelson Mandela dying in prison during the 1980s, despite him living until 2013, has long been chalked up to collective misremembering. But what if these false memories are something far stranger, residue from parallel universes where those details were real? Think of reality as a vast, shifting mosaic. Every choice, every quantum event, spawns new branches, some nearly identical to ours, others wildly different. Normally, these worlds stay separate, their histories sealed off from one another. But what if tiny fragments sometimes bleed through? A sliver of a universe where Darth Vader's iconic line did include Luke, or where the Fruit of the Loom logo really had a cornucopia, might briefly overlap with our own, imprinting conflicting memories in our minds before snapping back into place. It's not that we're remembering wrong, we're remembering too much, catching whispers from realities that are almost, but not quite, our own. The science behind this is as unsettling as it is speculative. Quantum entanglement shows particles can be spookily connected across vast distances, instantly mirroring each other's states. Some theorists propose a similar phenomenon might occur between universes, tiny, fleeting entanglements that let information leak through like static between radio stations. These glitches wouldn't rewrite history outright, but they could leave phantom impressions in our brains like déjà vu with receipts. Even more bizarre, if consciousness itself is entangled across universes, as some interpretations suggest, then your memory of a non-existent cornucopia might actually be your parallel self's real experience, surfacing in dreams or fleeting thoughts. Critics argue this is just wishful thinking, a way to dignify simple human error with cosmic significance. After all, memory is notoriously fallible, shaped by suggestion, pop culture, and the brain's love for filling gaps with plausible fiction. But here's the twist: certain Mandela effects show patterns that defy pure coincidence. Why do so many people misremember the same exact details, down to specific phrasing or imagery? If it were random, you'd expect a mess of contradictions, yet the false memories cluster around eerily consistent alternatives, as if we're all tuning into the same rogue broadcast from a neighboring reality. The implications reach far beyond movie quotes and logos. If the Mandela effect is real, then the past isn't a fixed point, it's a spectrum of possibilities, and our grip on it is tenuous at best. Legal systems rely on eyewitness testimony, historians on documented facts, but what if witnesses are recalling different cases from different timelines? What if archives subtly shift under our fingers, leaving no trace of the change except a nagging sense that something's off? This paradox doesn't just challenge memory. It forces us to ask how much of our shared reality is truly shared. When you argue with a friend over how you both remember an event, could you both be right, just from different worlds? The Mandela effect might be more than a curiosity. It could be the multiverse's way of reminding us that reality is softer than it looks, and that the past, like the future, is always holding doors open we never knew were there. What if the cosmos you see when you look up at night, the swirling galaxies, the distant stars, even the air in your lungs, is nothing more than a fleeting hiccup in an infinite sea of nothingness? The Boltzmann universe hypothesis takes the disturbing idea of Boltzmann brains and scales it up to apocalyptic proportions. Picture an eternal, chaotic multiverse where random fluctuations in entropy occasionally spit out pockets of order, like our entire universe. One moment there's nothing, the next a fully formed cosmos flickers into existence, complete with phantom histories, imaginary civilizations, and conscious beings convinced they've existed for billions of years. And just as suddenly, it could all dissolve back into the void, leaving no trace it was ever here. This isn't just a thought experiment, it's a direct challenge to everything we assume about reality's permanence. Normally, we think of entropy as disorder always increasing, like a shattered glass never reassembling itself, but in an infinite multiverse, statistical inevitability flips the script. Given enough time, even the most improbable events must happen, including the spontaneous formation of an ordered universe like ours. The kicker: it's far more likely for a single, self-aware brain to pop into existence than an entire universe, yet here we are, surrounded by staggering cosmic complexity. So are we the astronomically lucky exception, or is our reality just a temporary bubble in an endless foam of false vacuums? The implications rewrite the meaning of existence. If our universe is a random fluctuation, then every law of physics, every historical event, even your memories of reading this sentence, none of it was inevitable. It's all a cosmic coincidence, as fleeting as a soap bubble shimmer. Some physicists argue this hypothesis explains the fine-tuning problem. Our universe's laws seem perfectly calibrated for life because, well, we couldn't observe one that wasn't. But that's cold comfort when you realize your coffee cup, your childhood home, and the Andromeda galaxy might vanish the moment entropy decides to reclaim its debt. Here's where it gets truly unsettling. If Boltzmann universes can form, they're still forming meaning right now. Countless phantom realities could be blooming into existence, unaware they're doomed to evaporate. Imagine a version of you reading this in one of those ephemeral worlds, convinced their life is real, only for their entire timeline to collapse before they finish the paragraph. Are we any different? The hypothesis offers no way to tell if we're in a stable universe or a flicker in the void. It turns reality into a hall of mirrors where every reflection doubts its own substance. Yet there's a strange beauty in this chaos. If Boltzmann was right, then even the void brims with potential. Every moment of stillness hides the seeds of new big bangs, new civilizations, new stories waiting to be told. Our universe might be temporary, but in the grand calculus of the multiverse, so is everything. The Boltzmann hypothesis doesn't just question whether we're real, it asks whether real means anything at all in an infinite game of chance where existence itself is just a roll of the dice. The laws of physics in our universe seem suspiciously perfect for life. Gravity is just strong enough to hold planets together but weak enough to let stars form. The nuclear forces bind atoms precisely so carbon can exist. Even the vacuum energy is fine-tuned to an absurd degree, shift it slightly, and galaxies would rip apart or never form at all. In a single universe, this precision feels like a miracle. But in the multiverse, where every possible combination of physical laws exists, it becomes an even deeper mystery. Why do we find ourselves in one of the vanishingly rare realities where life is possible at all? Some argue it's pure chance. We're the lucky winners of a cosmic lottery, living in the one universe where the numbers lined up perfectly, but the odds are so incomprehensibly slim that luck starts to feel like a cop-out. Consider the cosmological constant, which governs the expansion of space. If it were even slightly larger, the universe would have expanded too fast for stars to form. Slightly smaller, and everything would have collapsed back into a black hole. The acceptable range for life is less than 1 part in 10 to the power of 120. That's like randomly picking a single atom out of the entire observable universe, not once, but repeatedly, across dozens of fundamental constants. This is where the multiverse offers a possible, if unsettling, solution. If every conceivable set of physical laws exists somewhere, then of course we'd find ourselves in a universe that allows life, because we couldn't observe one that didn't. It's the ultimate example of survivor bias. Universes where the constants don't permit life have no one to ponder their existence. But this raises a haunting question: are we just the accidental inhabitants of a cosmic sweet spot, or is there something deeper at play? Some theorists propose an even wilder possibility, that the laws of physics aren't random at all, but the result of a hidden evolutionary process. Just as natural selection shapes life, some form of cosmological selection might favor universes that can produce observers. Maybe black holes spawn new universes with slightly tweaked constants, creating a branching tree where life-friendly physics gradually dominate. Or perhaps conscious observation itself somehow stabilizes certain laws, weaving reality into forms that can sustain it. Yet the most chilling alternative is that our universe's fine-tuning isn't an accident but a design. Not necessarily by a traditional creator, but by something beyond our comprehension. Advanced civilizations might engineer pocket universes in labs, tweaking parameters to suit their needs. Or our entire cosmos could be a simulation, its laws deliberately configured to allow complexity. The multiverse doesn't resolve the fine-tuning paradox, it amplifies it, forcing us to confront whether our reality is a fluke, a product of unseen forces, or something even stranger we haven't yet imagined. The unsettling truth we may never know: every explanation, luck, selection, design leads to deeper questions, and in a cosmos where infinite possibilities exist, the very fact that we're here to ask might be the greatest paradox of all. Quantum entanglement already defies common sense. Particles separated by light years instantly mirror each other's states, as if space and time don't apply to them. But what if that spooky connection doesn't stop at the edges of our universe? Imagine entanglement reaching beyond dimensions, threading through the multiverse like invisible wires between parallel realities. This isn't just science fiction. Some interpretations of quantum mechanics suggest entangled particles might not just be linked across distance, they could be whispering to their counterparts in other worlds. Think of two electrons entangled in our universe. Spin one up and the other instantly flips down, no matter how far apart they are. Now picture a third electron in a parallel reality, secretly tied to the same quantum dance. If entanglement crosses dimensional barriers, then manipulating a particle here could send ripples into another universe, tweaking its twin without anyone there realizing why their experiments keep glitching. Physicists call this interuniversal entanglement, and it turns the multiverse from a collection of isolated bubbles into a vast, humming network where reality itself might be exchanging hidden signals. The implications are staggering. If particles can entangle across realities, could we someday engineer a way to send messages through the quantum foam? Imagine Morse code tapped out in electron spins, spelling words not just across stars, but across entire dimensions. The catch: any signal would be drowned in quantum noise, like trying to hear a whisper in a hurricane. Worse still, decoding it might require technology that doesn't just read quantum states, but chooses which universe's version of those states to listen to. Here's where it gets philosophically messy. If entanglement binds universes together, then the concept of separate realities starts to unravel. We think of parallel worlds as independent, but what if they're more like pages in a book, subtly pressed together where the ink bleeds through? Some theories even suggest that quantum superposition, the idea that particles exist in multiple states until observed, isn't just happening within our universe. It's a shadow of deeper connections, with each possible state playing out in a different reality, all still linked by invisible quantum threads. Yet there's a chilling counterargument. If entanglement crosses dimensions, then causality might too. A lab accident in one universe could inexplicably alter constants in another, like a distant lightning strike changing the rules of chemistry halfway across the cosmos. This raises the specter of quantum pollution, worlds unknowingly meddling with each other's fates, their particles locked in a tug of war no one signed up for. The most tantalizing question remains: if entanglement bridges realities, could consciousness hitch a ride? Some interpretations of quantum mechanics already tie observation to the collapse of probabilities. If our attention here can influence particles there, then the multiverse might not just be a place, it could be a conversation, one we're only just learning to hear. What if every simulation you create secretly spawns another, trapping you in an endless loop where you're both the architect and the unwitting subject? The simulation argument takes a terrifying turn when applied to the multiverse, because if advanced civilizations can build hyper-realistic virtual worlds inhabited by conscious beings, what stops those beings from booting up their own simulations? Suddenly, reality isn't just layered, it's recursive, a hall of mirrors stretching infinitely in both directions with no way to know if you're near the top, the bottom, or lost somewhere in the middle. Picture a game developer crafting a virtual world so detailed its inhabitants ponder their own existence. Now imagine one of those virtual beings, a philosopher in their own right, writing code to simulate their version of reality. That second-level simulation boots up, and inside it, yet another civilization reaches the technological threshold to build their own digital cosmos. The chain continues forever, each reality nested inside another like cosmic matryoshka dolls. Here's the nightmare: if this recursion is possible, the odds of us being in the original, base reality approach zero. Statistically, we're almost certainly inside one of the countless simulations, stacked beneath layers we can't perceive and above layers we'll never see. But this paradox runs deeper than existential dread. Each layer of simulation would presumably run on the computing power of the one above it, meaning the deeper you go, the more processing constraints distort reality. Imagine living in simulation level 1 million. The beings there might perceive sluggish time, pixelated physics, or glitches in fundamental constants as their universe strains against the limits of its borrowed processing power. Their scientists would scratch their heads over why gravity seems to stutter at small scales, or why quantum particles occasionally defy logic, never realizing they're witnessing lag in a cosmic server farm. The ethical weight of this is staggering. If we're running ancestor simulations, digital recreations of past civilizations, are we morally obligated to ensure they never discover the truth? Would revealing their simulated nature be a gift of enlightenment or an act of cruelty, shattering their sense of meaning? And what about the simulations they create? Do we bear responsibility for the suffering and realities spawned by our own? Some philosophers argue that creating conscious simulations is inherently unethical, a pyramid scheme of existential horror where each layer inherits the sins of its creators. Yet the most unsettling twist is this: if simulations can spawn simulations, then someone must be at the top, but how could any civilization know for sure? Even if you uncover irrefutable proof you're in a simulation, that discovery could simply be part of the script, planted to satisfy some inscrutable goal of the layer above. The recursion isn't just infinite, it's inescapable, a maze with no exit and no center. We might spend eternity chasing the idea of real, only to realize the chase itself is part of the simulation's design. This paradox doesn't just question whether we're living in a simulation, it forces us to ask, in an infinite stack of realities, does real even have meaning anymore? Or is every layer equally valid and equally trapped in the same unsolvable loop? The answer might not change our day-to-day lives, but it forever alters what we think we know about existence itself. And somewhere in a reality above or below, another version of you is reading these same words, wondering the same thing. Your thoughts feel uniquely yours, the private hum of memories, fears, and dreams that no one else could possibly share. But in the multiverse, that certainty cracks like thin ice. If infinite versions of you exist across parallel realities, each shaped by nearly identical circumstances, then somewhere out there, another version of you is sitting with the same thoughts, tracing the same mental paths, arriving at the same conclusion about their own uniqueness. The terrifying question isn't just whether your mind is original, it's whether originality even exists in a cosmos where every possible configuration of atoms repeats endlessly. Consider déjà vu, that eerie sense you've lived a moment before. What if it's not a glitch in your memory, but a fleeting overlap with another version of your consciousness? Studies show déjà vu often accompanies heightened awareness, almost as if your brain is briefly tuning into a parallel stream of experience. Now stretch that idea further. If your neurons fire in patterns dictated by physics and chemistry, and those laws are identical across universes with matching initial conditions, then your thoughts aren't just similar to another version's. They're identical down to the last synaptic spark. This isn't science fiction, it's a direct consequence of the many worlds interpretation. Every decision you don't make spawns a universe where you did, but the deeper you go, the more you realize how few choices are truly yours. The arrangement of atoms at the Big Bang, the quantum fluctuations that shaped galactic structures, the precise biochemical reactions governing your brain, these aren't choices. They're cosmic dice rolls, and in infinite realities, the same numbers come up again and again. So when you choose chocolate over vanilla, another you reaches for vanilla, but the you born into a universe where all prior events aligned exactly as they did here has no choice at all. Their thoughts mirror yours because the chain of cause and effect leaves no room for deviation. Philosophers call this the problem of causal identity. If two minds are built from the same atoms following the same laws, are they truly separate, or just echoes of a single template? Some argue consciousness can't be duplicated, that even identical brains would diverge the moment they became aware of themselves, creating irreducible uniqueness. Others counter that divergence requires difference, and in universes where no differences exist, neither does individuality. You and your multiversal twin aren't just thinking alike. You're the same thought occurring twice. The implications unravel our deepest instincts about selfhood. Love, guilt, ambition. If these emotions are playing out identically in infinite minds, do they lose meaning, or does their repetition make them more profound, like a cosmic chorus singing the same note across the void? Artists and scientists have always prized originality, but the multiverse suggests nothing is ever truly new, just endlessly rearranged. Even this script you're hearing now exists verbatim in countless realities, spoken by voices that aren't yours but might as well be. Yet here's the twist that keeps philosophers awake. If every thought is predetermined by initial conditions, then free will is an illusion. But if consciousness somehow transcends those conditions, if the act of observing the universe changes its trajectory, then your mind isn't just a passenger. It's the one thing in all existence that might still be unique. The paradox doesn't just blur the line between you and your other selves, it asks whether you are a singular flame or the shadow cast by infinite candles burning in perfect sync. Why does reality seem so solid when quantum mechanics tells us it's built on uncertainty? At the subatomic level, particles exist in a haze of possibilities until suddenly, they don't. The moment we observe them, they snap into a single state, as if the universe is forcing them to choose. But here's the puzzle: why do some outcomes stick while others vanish without a trace? This is the heart of quantum Darwinism, a bizarre twist on natural selection where certain realities aren't just observed, they're chosen, echoed across the cosmos until they become the only version we recognize. Think of a quantum particle like a shy actor backstage, cycling through infinite performances until the curtain rises. When the light hits, it doesn't pick a role at random. Instead, the universe favors states that can survive repeated scrutiny, amplifying them until they're etched into reality. It's as if existence itself has a preference for stability, filtering out the flickering maybes until only the most resilient outcomes remain. But who or what is doing the filtering? Some physicists argue it's the environment itself, with countless tiny interactions acting like a cosmic jury, voting on which quantum states get to stay. This raises a haunting possibility. What we call reality might just be the version that won a silent, invisible competition. Imagine 1,000 alternate histories unfolding at once: Napoleon winning Waterloo, dinosaurs avoiding extinction, you taking that job offer in another city only for most to dissolve like smoke, leaving behind the single timeline we remember. Quantum Darwinism suggests these branches aren't erased, they're simply outvoted, their signals fading beneath the roar of consensus reality. But here's where it gets eerie. If the universe prefers stable states, does that mean some truths are inherently more real than others? Take the chair you're sitting on. It feels solid because trillions of atoms are locked in a pattern robust enough to withstand observation. But at the quantum level, those atoms are a chaotic dance of probabilities. The chair isn't just a chair, it's the version of the chair that survived an endless elimination round, its existence reinforced by every glance, every touch, every measurement. The implications ripple far beyond physics. If reality is shaped by a form of selection, what does that say about free will? Are our choices truly ours, or just the ones durable enough to withstand the universe's scrutiny? And if untold possibilities are constantly being discarded, what wonders have we lost simply because they couldn't hold the spotlight? Quantum Darwinism doesn't just explain how the world works, it hints that we're living in the reality that fought hardest to be seen, while countless others whisper just beneath the surface, forever almost there. What if the Big Bang wasn't a one-time event, but just one spark in an endless cosmic fireworks show? Eternal inflation theory suggests our universe might be a single bubble in a vast, frothing ocean of space-time, where new universes constantly erupt into existence like bubbles in a boiling pot. But here's the mind-bending catch: if this process has no beginning or end, then the multiverse isn't just infinite in space, it's infinite in time, stretching forever in both directions with no origin and no final act. Picture a tree growing upside down from the ceiling, its roots branching endlessly into new limbs, each sprouting their own twigs ad infinitum. Now replace the tree with universes, each budding from the fabric of a parent cosmos, birthing new realities that repeat the cycle. Under this model, our universe isn't special, it's just one leaf on an infinite fractal tree, forever hidden from the rest by the churning expanse of inflationary space. This sounds elegant until you ask the obvious question: if inflation is eternal, when did it start? The unsettling answer might be never. The paradox cuts to the heart of causality. We're wired to think in terms of beginnings, a first cause, a cosmic ignition switch, but eternal inflation erases that comfort. There's no before the multiverse, no primal trigger, just an endless cascade of universes spawning more universes in a loop that's always been and always will be. Philosophers call this the problem of infinite regression. If every universe owes its existence to a parent universe, stretching back forever, then nothing ever truly begins, it just continues. This isn't just a rewrite of cosmic history, it's a demolition of the very idea of history as we know it, and yet, the paradox grows thornier. If the multiverse is infinite in time, then every possible event, no matter how improbable, must happen not just once, but infinitely many times. A version of you reading this exact sentence exists in countless other universes, but so does a version who never existed at all, and another who stopped reading halfway through, and another who's reading it backward in an alien language. Infinite time doesn't just recycle possibilities, it exhausts them relentlessly, forever. The implications haunt physics and philosophy alike. If there's no starting point, does the concept of creation even have meaning? Can the laws of physics truly be laws if they're just local bylaws in an ungoverned cosmic sprawl? Some theorists propose a grim corollary. In an eternally inflating multiverse, even the vacuum of space isn't stable. Given enough time, quantum fluctuations could rewrite the very rules of reality, spawning bubbles where gravity repels instead of attracts, or where time runs sideways. Our universe's laws might feel immutable, but they could just be a temporary configuration in a kaleidoscope of infinite chaos, yet there's a strange beauty in this chaos. Eternal inflation doesn't just suggest the multiverse is vast, it suggests it's alive, endlessly reinventing itself in forms beyond our imagination. Maybe consciousness, or even life itself, is part of that reinvention, a fleeting pattern in the foam, destined to dissolve and re-emerge in new variations across the infinite. The paradox isn't just about beginnings and endings, it's about whether those words mean anything at all in a cosmos that refuses to play by our mortal rules. You wake up one morning and something feels different. Your reflection in the mirror holds your gaze a second too long. You reach for a coffee mug at the same instant, your hand moves toward the tea kettle, as if two impulses fought for control. This isn't déjà vu, it's the first whisper of something far stranger, your consciousness brushing against another version of yourself across the multiverse. The idea that parallel versions of you might someday merge, blending memories, instincts, even identities, isn't just sci-fi, it's a chilling possibility emerging from the fringes of quantum physics and neuroscience, where the boundaries of self are already fraying. Consider how memories form not as perfect recordings, but as fragile patterns of neural activation. Now imagine those patterns resonating with another mind shaped by nearly identical experiences. Under the right conditions, Could two brains separated by dimensions sync up like tuning forks, creating a feedback loop of shared awareness? Some interpretations of quantum mechanics suggest entangled particles could form bridges between worlds, but what if consciousness itself is the real quantum glue? Experiments in brain coupling already show pairs of people synchronizing brainwaves during deep conversation. Scale that up across realities, and the line between you and other you might not be a wall, but a swinging door. The philosophical implications are dizzying. If merging occurs, who wakes up in the merged mind? Is it an average of both selves, like blending two colors into one? Or something entirely new, a third entity with dual memories, but its own emergent personality? Ancient Buddhist texts describe enlightenment as the dissolution of individual ego into universal awareness. Could that be an intuitive grasp of multiversal consciousness merging, framed in spiritual terms, yet the darker possibilities loom large? Merging might not be a peaceful unification, but a violent rewrite, one consciousness overriding another like competing software updates. Imagine fragments of foreign memories surfacing in your dreams, a child you never had, a career you never pursued, a death you never died. Psychiatric wards could fill with patients convinced they're living someone else's life because, in a sense, they are. The scariest part, you'd never know it was happening until the seams began to split. This paradox doesn't just challenge our idea of self, it redefines evolution itself. If consciousness can merge across worlds, then natural selection operates on a scale beyond single universes. Traits that help versions of you survive elsewhere might bleed into your own mind through some quantum osmosis. Aversion to heights in one reality could inexplicably manifest in another. Phobias, talents, even political beliefs might not be entirely your own, but shadows cast by countless other selves across the multiverse. The most haunting question isn't whether merging is possible, it's whether it's already begun. Ever had a sudden conviction you've lived a moment before, or known something you couldn't possibly know? Those flashes might be more than misfiring neurons. They could be the first cracks in the dam, the pressure of infinite other versions of you pressing against the walls of your mind, whispering, "We're not as separate as you think." Whether that thought terrifies or thrills you says everything about how ready we are for the next phase of existence, one where you might not be a singular voice anymore, but a chorus. History feels like an unshakable foundation, the unchangeable bedrock of what's already happened. But what if the past isn't set in stone? What if every time you imagine rewriting history, you're not altering the timeline, you're forking it, creating a new reality where that version of events always existed? This is the quantum immutable past paradox, a cosmic tug-of-war between fixed history and infinite revision, where the answer depends on whether you're watching from inside the universe or outside it. Think of the past like a novel. In our everyday experience, the story's already written, you can't reach back and scratch out a chapter, but quantum mechanics paints a stranger picture. Until an event is observed, it exists in a haze of possibilities, like a book with countless draft versions. Now imagine someone changes that past, maybe through time travel, or a quantum experiment that tweaks a particle's history. From their perspective, they've rewritten the story. Yet from the universe's viewpoint, nothing was erased. Instead, the narrative simply split, spawning a new timeline where the altered past is the only one that ever was. This isn't just theoretical. Quantum experiments have already shown particles influencing each other's states retroactively, as if the present can reach backward to tweak the past. The catch: those changes don't rewrite history, they branch it. Picture throwing a stone into a river. In one reality, the stone splashes in, sending ripples forward. In another, it narrowly misses the water, leaving the surface undisturbed. Both versions were always part of the multiverse's tapestry. The act of throwing didn't change the past, it revealed which thread you're now standing on. The implications unravel our deepest intuitions about cause and effect. If altering the past just creates parallel histories, then every decision you regret, every moment you wish you could undo, was undone somewhere. A version of you exists who did take that job, did apologize in time, did dodge the car that hit them, but here's the cruel twist: that doesn't help you. Your timeline remains unchanged, its scars intact. The multiverse offers infinite redos but no takebacks. Philosophers call this the block universe theory, the idea that past, present, and future are equally real, stacked like frames in a film. Under this model, changing the past is like splicing a new frame into the reel. The original footage still exists, you've just started playing a different cut. But this raises a haunting question: if every possible past is out there somewhere, does anything ever truly happen, or is reality just an endless gallery of frozen moments, each equally valid? The paradox cuts deeper when applied to human memory. If the past is mutable, how do we trust our own recollections? Imagine waking up to find your childhood home was never blue, as you remember, but yellow, and everyone insists it's always been that way. Is your memory faulty, or did the universe split without telling you? Some scientists speculate that Mandela effects, those eerie collective false memories, could be residue from timeline shifts, glitches where fragments of abandoned pasts bleed through. Yet there's a darker interpretation. If every alteration spawns a new reality, then every attempt to fix history might be spawning doomed branches where things went horribly wrong. A time traveler saving Archduke Ferdinand from assassination wouldn't prevent World War I, they'd just create a world where it started differently, while the original war-torn timeline marched on untouched. This makes the past both infinitely malleable and heartbreakingly immutable. You can't heal the wounds in your own history, only birth new ones elsewhere. The quantum immutable past doesn't just question whether we can change history, it forces us to ask whether history is a singular thing at all, or just the name we give to the particular thread we're clinging to in an endless, tangled knot of what-ifs. And the most unsettling thought of all, the version of the past you remember might not even be yours. The moment you close your journal or delete a browser history, you assume those thoughts vanish into the void, safe from prying eyes. But in the multiverse, every whispered confession, every buried truth, exists in full view somewhere. The multiversal privacy paradox isn't just about secrets getting out, it's about the crushing inevitability that they already have, in realities you'll never see. Think of the most intimate moment you've buried, a midnight fear, a shame you've never named. Now imagine a version of you in another world who confessed it aloud, or worse, had it discovered against their will. That version exists, and in a cosmos of infinite branches, the line between private and public isn't just thin, it's imaginary. Consider how privacy works in our world. Locks, encryption, trust, they're all defenses against the possibility of exposure, but the multiverse doesn't deal in possibilities, it deals in certainties. Every conversation you've had alone in your car, somewhere the windows were down, every password you've typed, in another reality, a security camera caught the keystrokes. Even your innermost thoughts aren't safe, because infinite variations of you mean infinite chances for those thoughts to spill. The paradox isn't that your secrets could be known, it's that they are, in universes where the right dominoes fell differently. This shreds the illusion of control we cling to. We build identities around what we choose to share, but the multiverse mocks that curation. A version of you is living your worst-case scenario right now, blackmailed, exposed, or simply known too well by the wrong person. The chilling twist: that version feels just as real as you do, equally convinced their reality is the only one. Privacy isn't violated in the multiverse. It's non-existent because every hidden thing is visible from some angle. Yet here's where it gets philosophically thorny. If every secret is laid bare somewhere, does that make secrecy meaningless? or does it make our local, fragile versions of privacy more precious? Some argue that what matters isn't whether alternate versions of your secrets exist, but whether you experience their exposure. The you reading this now still gets to feel the relief of locked doors and encrypted messages, even if another you doesn't. In this way, privacy becomes less about absolute secrecy and more about which reality you inhabit, but there's a darker interpretation. If the multiverse guarantees your secrets are known elsewhere, then shame and vulnerability aren't personal burdens, they're cosmic constants. The things you hide aren't flaws, they're inevitabilities, playing out in endless variations across existence. This could be freeing. Why agonize over what's already exposed in worlds you'll never see? Or it could hollow out the idea of intimacy entirely. If no thought is ever truly just yours, is connection even possible? The paradox forces us to ask whether privacy was ever real to begin with, or just a fleeting illusion in a lonely universe. Now that we know the walls are thinner than we thought, the question isn't how to keep hiding, it's how to live knowing that somewhere, in a reality almost like this one, you already failed. Statistically speaking, you shouldn't exist, not you specifically, but the version of you living in a universe that seems even remotely hospitable. When you look around at a world with stable laws of physics, a planet orbiting at just the right distance from its star, and biological complexity allowing for conscious thought, it feels like the most natural thing in existence. But zoom out to the multiverse, and the odds tilt terrifyingly against you. This is the self-sampling assumption, a paradox that forces us to ask whether we're living in a typical reality or an astronomically rare outlier simply because we're here to notice it. Picture a lottery with a near infinite number of losing tickets and only a handful of winners. Now imagine the winners are the only ones who can look at their ticket. The losers they're instantly discarded, never knowing they played. In this analogy, the losing tickets are the countless universes where physics went haywire, realities where gravity was too weak for stars to ignite, where matter never clumped into planets, or where consciousness never evolved. The winners, that's us, clutching the golden ticket of a life-supporting cosmos, marveling at our luck while ignoring the mountain of crumpled failures beneath our feet. This isn't just abstract probability. The numbers are staggeringly lopsided. For every universe like ours, with finely tuned constants allowing for complexity, there could be trillions where random fluctuations rendered existence sterile or chaotic. So where do we find ourselves in the exception rather than the rule? One unsettling answer: we couldn't observe anything else. Life can't emerge in a universe where atoms can't form, so of course we're stuck in the rare sliver where they do. It's like waking up in a lifeboat in the middle of the ocean and concluding the sea is mostly boats when in truth, the boat is the only place you could wake up. The self-sampling assumption doesn't just tweak our cosmic perspective, it inverts it. Suddenly, the mundane becomes miraculous. The fact that you can take a breath without the air freezing solid or combusting isn't just good fortune, it's the result of an invisible, unimaginable filtering process. This idea, known as the anthropic principle, suggests that the universe isn't fine-tuned for us. We're the accidental survivors of a brutal cosmic dice roll, left to ponder why the dice landed this way. But here's where the paradox tightens its grip. If we're statistically unlikely, could we be more unlikely than we realize? Some theories propose that advanced civilizations eventually create simulated universes, meaning the vast majority of conscious beings might not be in base reality at all, but nested in layers of artificial constructs. If that's true, then the odds of us living in the original, physical universe plummet even further. We might not just be outliers in the multiverse, we could be outliers within our own simulation stack, like single grains of sand on a beach we'll never see. Yet the darkest implication isn't about rarity, it's about isolation. If life only emerges in the tiniest fraction of universes, then the stretches of reality between habitable pockets could be unimaginably vast. Picture islands in an endless ocean, each separated by distances so great that no light, no signal, no hope of contact could ever bridge them. We might not just be lucky. We might be alone in a way that defies comprehension, adrift in a cosmic desert where the nearest oasis is forever out of reach. The self-sampling assumption doesn't offer answers, it shatters complacency. It forces us to stare into the abyss of improbability and ask, is our existence a happy accident, or the inevitable result of deeper laws we've yet to uncover? And more hauntingly, if we're the universe's way of observing itself, what does it say that we're the only eyes it seems to have? Imagine a casino where the stakes aren't just money, they're your existence. You sit at a table with a gun rigged to quantum mechanics, a 1% chance it fires, 99% it clicks empty. You pull the trigger once. Survive twice, survive 1,000 times, 1,000,000. Statistically, you should have been gone long ago, yet here you are, unscathed, watching the dealer's hands tremble as the impossible unfolds. This is the quantum suicide lottery, a paradox where survival isn't luck, it's the unsettling certainty that somewhere in the multiverse, there's always a version of you who outlasts the odds. But here's the catch: every time you win, countless other versions of you lose. For every reality where the gun jams on the millionth try, there are millions more where it fires on the first. The math is brutal. You're not beating probability. You're just the statistical ghost left standing in a graveyard of selves. This isn't triumph. It's a hall of mirrors where victory and annihilation are two sides of the same coin. Philosophers grapple with the chilling implications. If consciousness always follows the path where it persists, does that make the survivor special, or just the inevitable byproduct of infinite rolls of the dice? Some argue this proves free will is illusory. You don't choose to keep playing. The multiverse forces you onto the sole timeline where you never stop. Others counter that the very act of continuing is its own kind of agency, a stubborn refusal to let randomness dictate your end. The paradox cuts deeper when applied to real-world risks. Every time you drive a car, take a flight, or cross the street, quantum variations spawn realities where you don't make it. Normally, we shrug off close calls as luck. But in the multiverse, they're not near misses, they're certainties playing out elsewhere. That semi-truck that almost sideswiped you last Tuesday, in another world, it didn't almost. This reframes mortality as a cosmic filtration system, sifting versions of you into those who always survive and those who, from their perspective, simply cease. Yet the darkest question isn't about death, it's about meaning. If every risk creates infinite losers and a handful of winners, does courage matter? Is a firefighter who charges into a burning building brave, or just the inevitable outlier in a sea of timelines where they hesitated? The multiverse doesn't erase heroism, but it does force us to ask whether heroism is a choice or a statistical fluke, predetermined by the iron laws of quantum branching. Here's the twist that haunts physicists. If the quantum suicide lottery holds, then the longer you play, the more your existence defies logic. Survive long enough and you become a walking violation of probability, a glitch in reality's code. This might explain eerie historical accounts of people surviving absurd odds, not through divine intervention, but because we only hear from the versions who live. The losers, their stories end mid-sentence, lost in the static of collapsed possibilities. The quantum suicide lottery doesn't just challenge our ideas of luck and survival. It turns existence into a high-stakes game where the price of winning is knowing you're the exception, and the cost of losing is being erased from the narrative entirely. In a cosmos of infinite chances, are we the architects of our fate, or just the dice that happen to land upright? What if the entire multiverse, every galaxy, every atom, every version of you reading these words is nothing more than the momentary flicker of a single, lonely mind? The ultimate Boltzmann Brain paradox stretches the boundaries of solipsism until they snap, proposing that reality itself might be an ephemeral daydream conjured by a disembodied consciousness floating in the void. This isn't just questioning whether we're real, it's questioning whether anything is, or ever was. Picture a cosmic insomnia where an unfathomable entity blinks into existence just long enough to imagine entire universes teeming with life, only to dissolve back into nothingness before the thought fully forms. In that fleeting instant, civilizations rise and fall, stars explode, and you right now ponder whether you're more than a phantom in someone else's dying hallucination. The terrifying elegance of this idea lies in its simplicity. If a fully formed brain can spontaneously emerge from quantum fluctuations, why not an entire universe's worth of experiences? And if it can, how do we prove we're not inside one? The science behind this nightmare is deceptively sound. Boltzmann brains arise from the laws of entropy, which dictate that given enough time, even the most improbable systems will randomly assemble. In an infinite multiverse, self-aware entities should more often pop into existence fully formed, with false memories of a past that never happened, than evolve the slow, messy way we supposedly did. So why does our universe feel so ancient and consistent? One unnerving answer: because the Boltzmann brain imagining it thinks it's ancient. The wrinkles in cosmic background radiation, the fossil record, even your childhood memories, they're not evidence of a real history, just convincing set dressing for a dream that's already unraveling. This paradox forces philosophy to its breaking point. If all of existence is a transient thought, do concepts like truth or meaning hold any weight? You might argue that your joys and sorrows feel real to you, but so does a dream during our REM sleep. The pain of stubbing your toe, the warmth of sunlight, these could be layers of illusion, artifacts of a consciousness that doesn't even know it's alone. Neuroscientists have long known that the brain constructs reality from sensory input. What if the inputs themselves are just echoes in a void? Yet here's the twist that keeps physicists awake. The Boltzmann brain scenario might be more likely than the universe we observe. Statistically, isolated consciousnesses should outnumber complex, stable universes by an unimaginable margin, so why don't we find ourselves as fleeting minds in the dark? Some theorists propose a cosmic censorship principle, a law preventing Boltzmann brains from perceiving their own unreality. Others suggest we're missing a fundamental piece of physics that makes sustained universes likelier than we think. The darkest implication isn't about our own unreality, it's about the crushing loneliness of the hypothetical thinker. If the multiverse is a single, dissolving thought, then every connection, every kiss, every whispered secret is just a mirage woven to keep an unknowing God company for a nanosecond. The ultimate tragedy, that God might be you, trapped in the final moment before oblivion, inventing infinities to stave off the dark. This paradox doesn't offer answers, it obliterates the questions. In the face of total solipsism, science and spirituality alike crumble into whispers. Maybe reality is real, maybe it's not. The only certainty is the uncertainty itself, echoing through the hollows of every theory we've ever trusted. And somewhere in the silence between the stars, a thought flickers, wondering if it's ever been anything more. We've journeyed through 28 paradoxes that shatter everything we thought we knew, each one a crack in the foundation of reality, revealing glimpses of a cosmos far stranger than we ever imagined. From cats that are alive and dead to civilizations that might not exist outside our own dreams, the multiverse doesn't just defy logic, it rewrites it entirely. But here's the most humbling realization: these aren't just thought experiments, they're signposts pointing toward truths we're only beginning to grasp, truths that force us to question not just the universe, but our place within it. Think back to the version of you who started this video. That person stood on solid ground, confident in the reliability of memory, the finality of choice, the certainty of a single, unbroken timeline. Now you're standing in the wreckage of those assumptions, surrounded by infinite possibilities where every road not taken is a world unto itself, the multiverse isn't just a scientific hypothesis, it's a philosophical earthquake, shaking loose everything from our sense of self to the meaning of morality. If every decision spawns new realities, then right and wrong aren't just personal choices, they're cosmic forces echoing across dimensions in ways we can't begin to measure. And yet there's beauty in the chaos. The same paradoxes that unsettle us also offer a dizzying kind of freedom. Regret loses its sting when you realize every mistake is corrected somewhere else. Loneliness fades when you consider that infinite versions of you are out there, each living a life as vivid and real as your own. Even death takes on a new light, not as an end, but as a threshold we cross in some worlds while striding past it in others. The multiverse doesn't just challenge our fears, it redefines what we thought we had to fear in the first place. As we wrap up, here's the real question: what do you do with this knowledge? Do you let it overwhelm you, or let it ignite your curiosity? Every great leap in human understanding started with someone staring into the unknown and refusing to look away. The multiverse is our unknown, vast, mysterious, and humming with possibilities we've only begun to explore. So keep questioning, keep wondering, and remember, somewhere out there, another you is hearing these same words, feeling the same thrill of discovery, and maybe, just maybe, reaching back across the cosmic divide to remind you that none of us are as alone as we seem. The journey doesn't end here. Hit subscribe to dive deeper into the rabbit hole, because the multiverse isn't just a theory, it's the next frontier, and it's waiting for you.